So today we're going to learn about two more parts of a triangle. We're going to learn about the medians and the altitudes. So this is section 4. So the first one is the median of a triangle, and this is going to be a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So every triangle will have 3 medians, and the medians are going to be concurrent. Okay, so right now I've only got one median drawn in here, and it's coming out of vertex C. I could draw another median. The medians, remember, go from the midpoint to the vertex. So you find the vertex, and then you go over to the side across from it, and it hits the midpoint. So that would be another median in this figure. And then I can draw another one coming out of vertex A, and it's also going to hit the midpoint of the side across from it. The point where they all cross, and that's on the next slide, that is going to be called the centroid. Okay, this point where they all meet, this point of concurrency, is always inside. And it's going to say that on the next slide. Okay, so for example, if I ever ask you to graph 3 ordered pairs and find the coordinates of the centroid, you need to draw in the 3 medians. Know that the median goes from the vertex to the midpoint, and then you would find the points where the lines cross. On the next slide, here is the name of that point of concurrency, and it's called a centroid. So the point of concurrency of the 3 medians of a triangle is called the centroid of the triangle. This centroid is always inside the triangle. Another name for centroid is center of gravity, and that would be the point where a triangular region would balance. Like if you put a triangle on the pencil, that point would be where it could balance perfectly. Next is the theorem about the concurrency of the medians. And the medians of the triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So before we would see that pieces would be congruent, but this one is going to be 2/3 the length of the median. So what it's referring to is, for example, this median here, and I'll highlight it in red. This piece of the median from A to P, so from the vertex to that centroid, would be 2/3 the length of the whole thing. This little piece over here, the PE, would be 1/3 the length of the entire median. So they have some formulas there. So for example, the length of AP is 2/3 the length of the entire median, which is AE. Then you can go and find the other median. So let's say we have BP here, or BF first, and then the length of BP is 2/3 the length of the entire median. And then you have this other median, which is CD, and then you could see that from the vertice to the midpoint, or to the centroid, this is also 2/3. So it splits it into 2/3 and 1/3. So let's practice it. So here is a triangle. It has the medians drawn in there. It's giving us the length of RL, which is here. And they want us to find the length of LS, which is this part here. Remember, the length or the distance from the vertex to the centroid will be 2/3 the length of the entire median. So the formula I'm going to use here is I'm going to take LS is equal to 2/3 the length of the entire thing, which is RL. They told me RL equals 21. So I'm going to multiply 21 by 2/3. I can go ahead and simplify diagonally here, change the 3 to a 1, 21 to a 7. So LS is equal to 14. Now, I know it's not asked here, but what if I ask you to find the length of RS? What could I do? Ashley? Beautiful. So I could take that 21 and I could multiply it by 1/3. So RS is equal to 7. Now, let's say I forgot that. What other way? If I found the length of LS is 14 and I knew the whole thing was 21, what's another way I could have done it?
You could subtract it.
Beautiful. Okay, so another way to double check your answers is you could have subtracted what you got, and that should give you that piece. So again, remember, if you go ahead and do them individually, this plus this needs to equal the entire median length. Now let's go back, and now part B is asking us for NQ. So NQ is this whole length of the median, and they gave us the little piece. They gave us SQ. Now SQ, is this the 1/3 portion of the median or the 2/3? Beautiful. Okay, so we can tell that that's the 1/3 part because that's from the centroid to the side. The portion that's from the vertex to the centroid is the 2/3. So to find the length of this, I'm going to do 1/3 times NQ equals SQ. So 1/3 NQ, SQ was 4. To solve this, I'm going to multiply both sides by 3. And the length of NQ, or the entire median, is 12.
Wait, multiply by 3.
Okay, so it's 4 times 3, so it's 12. So here, a sculptor is shaping a triangular piece of iron that will balance on the point of a cone. At what coordinates will the triangular region balance? What point of concurrency am I looking for? What's the name of it? The centroid. Good. So I'm looking for the centroid because that's my center of gravity. So I'm going to draw in my medians to find the coordinates of the centroid. So what I need to do is find all of the midpoints, and then I draw from the midpoint to the vertex. Once I've drawn in all those medians, I'm going to see the point where the 3 medians cross. So let me go ahead and calculate the median or the midpoint, for this side. So I'm going to take 6 plus 8, divide by 2, 6 plus 2, divide by 2. This gives me 14 over 2, 8 over 2. This gives me the order pair 7, 4. That is the midpoint of this side. So I can draw my median. The median. So I'm going to draw on the median. So it goes from here to the vertex right across from it. Next, I'm going to find the midpoint for these two. So I'm going to do 6 plus 10. Let me do it in a darker color. 6 plus 10, divide by 2, and 6 plus 7, divide by 2. This will give me 16 over 2 and 13 over 2. So this is going to give me the midpoint at 8, 6.5. So if I come over here, my midpoint is right here. Draw the median, it goes to the vertex. I have one more midpoint to calculate, and we'll do this one over here. So I'm going to take 10 plus 8 and 7 plus 2. Divide them both by 2. 18 over 2 and 9 over 2. So this is going to give me the order pair 9, 4.5. So I'll come over here and plot it. Draw in the median. And let me do this in a different color. Let's do it in red. Okay, so now I have my 3 medians drawn in there. So now to find the point of concurrency, which is the centroid, I'm going to figure out what this order pair is right smack in the center. And this order pair is going to be the order pair 8, 5. And that would be the point that the region would balance. So let's say you're doing this and your graph's messy. You can find the length of that median and figure out 2/3 of it, and then figure out the point by using the distance formula too. But the easiest way is just to be careful. I'll give you a coordinate plane to graph it, so that way you can precisely see where it is. Next piece of the triangle we're going to talk about is the altitude of a triangle. An altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. The altitude could be inside, outside, or on the triangle, just like the perpendicular bisector. Remember, when it was an acute triangle, it was inside. When it was a right triangle, it was on the triangle. And when it was an obtuse, it was outside of the triangle. In this picture here, the black triangle is an obtuse triangle. Notice point P is where they're all meeting, and that's our point of concurrency. So the point of concurrency where all of the altitudes meet is called the orthocenter. So in triangle QRS, altitude QY is inside the triangle, but altitudes RX and SZ are not. So notice the lines containing the altitudes. They're all concurrent at point P, which is outside of the triangle. So when it's an obtuse triangle like this one, the point of concurrency, this point P, is outside of the triangle. When you're drawing in these altitudes, you may have to rotate your picture or your paper. I know sometimes it might be kind of hard when you're trying to do it on your iPad. All right, so for example, this altitude right here, when I draw it from the vertex straight down, there's an altitude there. The altitude that's coming out of R, however, now notice it could hit the side, so we may have to extend the side in order to get an altitude to touch it perpendicularly. And then for the altitude that's coming out of S, again, we had to extend this side of the triangle, and it comes down and it hits here. Now, I can keep extending these altitudes until all 3 of the altitudes cross. And again, their point of concurrency is at point P. Now, I'm going to change one of the coordinates. I'm going to change 2 of the coordinates here. I think on your slide, this one is different. What is it? 3, -2. All right, I'm going to change mine to that. But I'm going to change Z, and I'm going to make it 7, 2. Let's graph the 3. I'm going to graph X, 3, -2. Then I'm going to graph Y, 3, +6. And then I'm going to graph Z at 7, 2.
We do 7, 2 or 7, 1?
I'm going to change it to 7, 2. So change it to 7, 2. I'm going to connect the points, and I'm going to make my triangle. Now, again, what we're going to do here is figure out what kind of triangle I've got. Now, first thing I'm going to try to do is see if this sort of looks like it might be a right triangle. So what I'm going to do is to confirm that I do have a right angle here, is I'm going to calculate the slope of this line and this line to see if they're opposite reciprocals. Okay, then from there, I can decide where my orthocenter is going to be. So if I go ahead and calculate the slope, let me go ahead and write the ordered pairs here. This is 3, 6. This one was 7, 2. And then 3, -2. So I'm going to calculate the slope of these two. So if I do y2 minus y1 over x2 minus x1, I could also count the slope, but I'll just do the formula. So I'm going to do 6 minus 2 over 3 minus 7. I get 4 over negative 4, or negative 1. Now I'm going to calculate the slope of this line to see if it's opposite reciprocal. So here I could do 2 minus negative 2 over 7 minus 3 and get 4 over 4, which gives me positive 1. These are opposite reciprocals, so I do realize that this is a right triangle. So this tells me that my orthocenter will be on the triangle, and all I have to do is show that this right here, this is the perpendicular distance here, but the perpendicular distance coming out of vertex y is this line right here. And the perpendicular segment coming out of x is this one. So my point of concurrency here is z, and it's 7, 2. So just keep in mind, whenever you have a right triangle, know the point of concurrency is going to be on the triangle. If it were acute, it would be inside, and obtuse like the previous slide, it would be outside of the triangle.